here we are given this piecewise function. I know it's a piecewise function because it says f of x is equal to, and here we see two different lines, right? So there's two different pieces of this function. Okay, so what we want to do is we want to evaluate this function at these three x values, and then we want to sketch this graph. Okay. Now, what I like to do, I just like to rewrite these using different pieces, right? We know that f of x is going to equal negative x squared plus 2, but that is only for values of x that are less than 1. Okay. So if we're going to evaluate this for any values of x less than 1, we want to use this piece of the function. And what about the other one? F of x is going to equal what? 2x plus 3. Okay. But that is for any value of x that is greater than or equal to 2. Okay. So we can do one quick little thing here, right? Well, what about values between 1 and 2, right? Okay. So notice this is less than 1 and this is greater than or equal to 2. Okay. So essentially we cannot evaluate this function for any value of x between 1 and 2. Okay. We'll see that here in a little bit. All right, let's evaluate these. Let's answer these questions first. Right, we're going to evaluate first of all. Okay, what is f of negative 2? So how do we do this? Okay, remember you're not going to plug in negative 2 into both parts and then give me two different answers, right? We can only have one answer. So how do you know which part or which piece of the function to evaluate this in? And it all depends on the domain, right? So okay, negative 2 is certainly less than 1. So for f of negative 2, we want to use this part of the function. So f of negative 2 is negative of negative 2 squared plus 2. Okay, now, by the order of operations, that negative 2 squared is positive 4, but times that negative 4 plus 2, which gives us a negative 2, right? What about f of 1? Okay, same idea, right? We have to determine which piece of the function 1 belongs to. Well, wait a minute. This says x is strictly less than 1. So 1 does not belong to this piece. Wait a minute here, x is greater than or equal to 2. 1 is certainly not greater than or equal to 2, so 1 does not belong to this piece either. So what's our conclusion? If we can't use this piece, or we can't use this piece, then what can we conclude? We can conclude that 1 is not in the domain, so we actually cannot evaluate this. This does not exist. Okay, don't put 0, right? 0 is an actual number. Okay, 0 doesn't mean nothing in math. Okay? I mean, if you're talking about money, right? 0 means no money, but this is math, right? 0 is an actual number. Okay. So what about f of 3? Well, 3 belongs to which piece? The top piece or the bottom piece? Well, 3 is certainly not less than 1, but it is greater than or equal to 2. So to evaluate f of 3, we want to plug that guy in here, right? So 2 times 3 plus 3. 2 times 3 is 6. 6 plus 3 is 9. All right, so how are we going to graph this guy? Well, similarly, right, it's a piecewise function. There are two different pieces of this function here, right? So we just have to essentially draw both pieces on the same coordinate axis here, right? All right, so let's do this one here, right? How are we going to draw this? Now, this is an x squared, which is a parabola. It's negative. We're going to have a little bit of an upside down parabola here. Okay. It's actually going to be a move up 2 units. Okay, and well, let's make a table, right? And when x is 0, I know that y is 2. Okay. When x is 1, right? Negative 1 plus 2 is positive 1. When x is negative 1, it's negative 1 squared. Negative 1 plus 2 is also a positive 1. What about when I plug in negative 2 here, right? We already got that answer. When x is negative 2, the y value is negative 2. When x is negative 3, we get negative 9 plus 2, which is negative 7, right? So we're going to get negative 3, comma, negative 7. Negative 2, negative 2. Negative 1, 1. Boom, boom, right? It's like I said, it's an upside down U. But remember, don't draw the whole U though, right? This is a piecewise function. We're only going to use the left side of this from positive 1. Okay? We should put an open circle here. Okay? Now this graph, 2x plus 3, right? What are the characteristics of this graph? This is a line, right? This is a line. The y-intercept is positive 3. Okay? The y-intercept is positive 3. And the slope is 2, right? So we're going to go here. And the slope is 2, so up 2 over 1. Yeah, but remember, we only use this part of the graph for values of x that are greater than or equal to 2. Okay, so when x is 2, 2 times 2 is 4, 4 plus 3 is 7, right? So I guess I should extend this graph up a little bit here. Okay. So we're going to, for 2, right, I know that that y value is 7. And then when x is 3, I know that the y value is 9. So we're just going to draw this line going up and to the right in that direction. Here it's greater than or equal to, which means we can use a, or not can, we must use a closed circle here. So this will be our graph, right? It's going to be a little bit of an upside down parabola up until positive 1. And then from 2 to the right side, right, it's just going to be this line.